Hello, this video is for IXL Activity A1.E.2. It is titled Convert Rates and Measurements Using Metric Units. The 3-character code for this activity is 6 Whiskey 2. So metric units, well, they're like the opposite of customary units. We did a lesson with customary units dealing with gallons and quarts and inches and miles and pounds and tons, those type of things. And those customary units are typically what's used mostly here in the United States. However, the rest of the world, and some stuff in the United States, but the majority of the rest of the world functions on what is known as the metric system. So we're going to be talking about converting metric units and rates and measurements. All right, so here's a metric conversion chart here. But first, let's talk about the base units for the metric system. In the metric system, we can measure length, weight, and capacity, that is to say volume. And for length, the base unit is the meter. Now you can also use kilometers and centimeters, but we'll talk about that in a moment. For weight, the base unit is a gram, and for capacity, the base unit is a liter. So if we look over here where we see base unit on our conversion chart here, so our base units are a meter. Go ahead and put these in here. We could have meters as a base unit. We could also have grams as the base unit. And then finally, we might also have liters as a base unit as well. So this is the base unit here. And by base unit, I mean that this is like just one of those. Or we could say 20 meters or 50 liters or what have you. But let's say that we said 1,000 meters. Well, instead of saying 1,000 meters, we could just have 1 kilometer. And so you'll see kilo out here on this end here. So basically, these other measurements here, notice that these are prefixes that would go in front of the base unit. Like kilo is 1,000 units. So if you had 1,000 meters, then you could say that you had 1 kilometer. Or if you had 10 meters, then you would say that you have a 1 decameter. So see how we're using the prefixes and then attaching them to the base units, or you might say the root words, and creating new words that represent a certain measurement. For instance, down here at milli, this is the 1 is in the thousands place, so it takes 1,000 of these to equal 1 base unit. So if you had 1/1000th of a gram, you could say that you have 1 milligram. Or if you had 1/10th of a liter, you could say that you have a deciliter. It's a good idea to memorize these, but for this activity, basically the ones that you're going to need to know are centi and milli over here on the less than 1 side. 100 of these equals 1 base unit. 1,000 of these equals 1 base unit. Now also notice that these are just 1 decimal part. So that means if you have 10 millimeters, that would be equal to 1 centimeter. So 10 of these equals 1 of these. 10 of these equals 1 of these. Also, if you go by place value here, by the number of places that you jump whenever you go from one to the other. So if 10 of these equals 1 centimeter, then 100 of these would equal a decimeter, and 1,000 of these would equal a base unit, or a meter, right? Or grams, all depends upon whichever one you're talking about there. All right, so with that in mind, let's also look at this little tip that we have here on the conversion chart. To convert to a smaller unit, move the decimal point to the right or multiply. To convert to a larger unit, move the decimal point to the left, or that is to say, divide. So if we have, and let's take this first example, 74 liters. 74 liters. And I want to go to milliliters. Well, notice that milliliters is down here. So I need to go 1, 2, 3 places. So I'm going to take that 74 and move the decimal over 1, 2, 3 places. Put in some place holding zeros in there, and you see that I end up having 74,000. So 74,000 milliliters. So 74 liters is equal to 74,000 milliliters. Basically, the key to this is how many places do we have to move? Well, we're going from the base unit of liters. We got to get to the prefix of milli. It is 3 units to the right, 1, 2, 3. So we're going to move the decimal 1, 2, 3 places to the right, which is what we've done here. So if we're going to the left, say we're going from meters, and we're going to go to kilometers, well, notice that's 1, 2, 3 movements to the left. So the decimal is going to move those same number of units or same number of place values to the left as well. Hope I've kind of explained that halfway decent. Let's look at some examples and see. So here we have 606 liters, 606. Let's go ahead and put that decimal there, liters, L-I-T-E-R-S. And we need to get to milliliters. Well, remember we have liters, then we have deciliters, and then we have centiliters, and then we have milliliters. Well, we need to get to milliliters, so we need to go 1, 2, 3 places to the right. So we're going to move that decimal over. Let's give myself room. 1, 2, 3 decimals to the right. So we're going to put in 3 place holding zeros. So we end up with 606,000 milliliters. See, so we're going from a larger unit to a smaller unit. We move the decimal to the right. That means the number is going to get greater, because if we're going to the right and we're going to a smaller measurement, we need more of those to be equal to that amount that we started with, if that makes sense. But the key thing is we're going from liters down to milliliters. We're moving to the right, so the decimal is going to move to the right. On the next one, I have 65,000 milliliters, and I need to get to liters. So I'm down here at milliliters, right? And I need to get back to liters. In between that is centiliters and deciliters. So I need to go 1, 2, 3 places to the left. So I'm going to move my decimal 1, 2, 3 places to the left. So 65,000 is going to become 65. So 65 liters. Now we need to use conversion factors, because now we're getting a rate. These are rates, right? A rate set up as a fraction. It's a proportion, but we set it up as a fraction. The numerator and the denominator have different measurements, and they're unlike a conversion factor. They are not necessarily equal to 1. So let's go ahead, and if you're unfamiliar with conversion factors, be sure to check out the video that we did for customary units. That would be the activity right before this one. So I have 38,400 meters, and that is for every 1 hour. Now I need to get from hours to minutes and meters to meters. So I'm okay on the meters part, but I need a conversion factor that's going to take me from hours to minutes. So again, like we did in the last one, I want hours to cancel. So since hours is in the denominator, for my conversion factor, I'm going to put it in the numerator. Hours to minutes, and I guess I'll put MIN so we don't confuse it with the meters. And 1 hour, there are 60 minutes. So I think I'm good to go now. Hours is going to cancel hours. I have meters in my denominator, or numerator. I have minutes in my denominator. So now I just multiply straight across. 38,400 times 1 is 38,400. 1 times 60 is 60. Now this is 38,400 meters per 60 minutes. But I need to know for just 1 minute. So now we need to get to what we know as a unit rate. And whenever we did unit rates, we learned that we just divide both the numerator and the denominator by the value of the denominator. So 60 divided by 60 is going to be 1. And then let me turn on my calculator here. 38,400, going to divide that by 60. And that's going to give me an answer of 640. So 640 meters in 1 minute. Put that 0 back on there. 640 meters per minute. Here we have another one where we had to do some converting. We're going to go centimeters to centimeters, so no change there for that, but we do need a conversion factor to take us from days to hours. So 58,992 centimeters per 1 day. And now we need a conversion factor that's going to take us to hours, right? So we have day in the denominator, so let's put day in the numerator, so those will cancel. And then we can go days to hours, right? That should work. In 1 day, there are 24 hours, right? I think we have everything we need. Days is going to cancel days. In our numerator, we have centimeters. In our denominator, we're left with hours. And centimeters per hour is indeed what the answer is asking for. So 58,992 times 1 is 58,992. And 1 times 24 is 24. So we now have 58,992 centimeters per 24 hours. But we want to know for just 1 hour. So again, we're going to have to go to a unit rate. And we know we get unit rates by dividing both the numerator and the denominator by the value of the denominator. So 24 divided by 24 is going to be 1. And 58,992. And I'm going to divide that by 24. And that's going to give me a result of 2,458. So our answer is 2,458 centimeters per hour. Next one, we're going deliveries to deliveries. Now you're like, what kind of measurement is that? Well, we know we don't have to convert, right? Because it doesn't change, but weeks to hours does. So 29,232 deliveries. We'll just go D for deliveries. Now, to be quite honest, I'm kind of curious why they're doing deliveries in weeks whenever this really isn't part of the metric system. Deliveries is not part of the metric system, and the metric system doesn't really have, they still work in hours and so forth. But at any rate, we don't need an equal sign. We need to go ahead and use a conversion factor, right? I'm so distracted by talking about that doesn't really belong here. But at any rate, so we need to go weeks to hours. So weeks to days. Let's do a weeks to days. Then let's do a days to hours. Days to hours. I'm using 2 conversion factors here, and notice that whenever I set it up, weeks is in the denominator, so I put the new one in the numerator. That means days is going to have to go in the bottom, which is the denominator. So on my next conversion factor, I'm going to put days in the numerator, since over here it's in the denominator, and then I'm converting to hours. And this is going to work out rather well because things are going to cancel. But before we do that, let's go ahead and put in our values on our conversion factors. In 1 week, there are 7 days. And in 1 day, there are 24 hours. So now we can go ahead and cancel stuff. Weeks cancels weeks. Days cancels days. Let's see if this works out. We have deliveries in our numerator. And we have hours in our denominator. And deliveries per hour is exactly what they're asking for. Next, we need to do 29,232 times 1 times 1, which is going to still result in 29,232. And 7 times 24, can I mental math that? 7, 140 plus 28, 140, 168. Let me double check that. 24 times 7, 168. Indeed it is. 168. I always kind of like to keep myself sharp on that mental math stuff. All right, now I have the total for 168 hours, but I need to know for just 1 hour. So right now I have a rate, but it's not a unit rate, and I indeed need a unit rate. So in order to get a unit rate, I'm going to divide both the numerator and the denominator by the value of the denominator. 168 divided by 168 is 168, and 29,232 divided by 168 is going to be a result of 174. And for those of you saying that's supposed to be a 1 in the denominator, you would be correct. So 174 deliveries per hour. On the next one, we're going, finally, we're changing both the milliliters to centiliters and we're changing minutes to hours. So we're going to need a few conversion factors here. So let's start off with our 380 milliliters in 1 minute. And I'm going to go ahead and do MIN for minutes so I don't confuse it with the milliliters. Now let's go ahead and do the time conversion first. Let's do minutes, again, so they'll cancel, and minutes to hours. In 1 hour there are 60 minutes. Now I need to do a conversion factor to get from milliliters to centiliters. Now milliliters is up here in the numerator, so I'm going to put this in the denominator. And then centiliters I'm going to put here. Now if you think back to that chart, milli and centi are just 1 unit away, right? It takes 10 millis to equal 1 centi. So it takes 10 millis to equal 1 centi, or that is to say that 1 centiliter is equal to 10 milliliters. Now I think we're good to go. We can do our canceling. Let's see, minutes will cancel minutes. Milliliters will cancel milliliters. I'm left with centiliters and hours, which is exactly what I want here. So 380 times 60, 380 times 60 is going to give me 22,800, 22,800. And 1 times 1 times 10 is 10. Ooh, I can do this one without any calculator here. So now I need a unit rate, not 10, for 10 hours, but for 1 hour. 10 divided by 10 is 1, and 22,800 divided by 10 is going to be 2,280. How did I do that mentally? I'm dividing by 10, so I just drop a 0 off the end there. Notice, same number, just has 1 less 0. So it is 2,280 centiliters in an hour. On the next one, we're going kiloliters to liters, and we are going weeks to hours. So 504 kiloliters in 1 week. Now let's do our time conversion. All right, let's do weeks in one. How many weeks are number of days? And then to get to hours, we're going to do a number of days to hours. Let's go ahead and fill these numbers in. In 1 week, there are 7 days. And in 1 day, there are 24 hours. So we have our time conversion factors here to get us from weeks to hours. Now we need a conversion factor to get us from kiloliters to liters. So if you think back to that chart, kilo is up here, then there's hecto, and then there's deca, and then there is the base unit, right? The base unit here. So the base unit is indeed liters. So we are moving 1, 2, 3 units to the left, or that is to say that it takes 1,000 of these to equal 1 of these. So let's go with kiloliters in the denominator, since it's in the numerator over here, and I want liters here, and it takes 1,000 liters to equal 1 kiloliter. So I think we're set up, good to go. Weeks will cancel weeks, days will cancel days, kiloliters will cancel kiloliters, leaving us with liters in the numerator and hours in the denominator, which is what we want, liters per hour. Now, 504 times 1 times 1 times 1,000 is 504,000. And 1 times 7 times 24 times 1. Didn't we do this 7 times 24 before? 168. Isn't that what it was? 7 times 24 indeed is 168. And now we need a unit rate. So we need to know number of liters in just 1 hour. We do that by dividing both values by the value of the denominator. 168 divided by 168 is 1. And 504,000 divided by 168 is the result of 3,000. So the answer is 3,000 liters in 1 hour. I was thinking maybe this is finally my last one, but apparently not. I got plenty of these here for examples. So we want to go 70,524 kilograms in 1 hour. And we need to get to over hours to hours. So we just need a conversion factor to take us from kilograms over to grams. So remember, kilos over here, hecto, deca, base unit, right? So this is grams. And remember, it takes 1,000 of these to equal one of these. So we're going to go with it takes 1,000 grams to equal 1 kilogram. Kilograms will cancel kilograms, and that's going to give us grams in an hour. So we're good to go there. All right, we're going to take 70,524 and multiply it times 1,000. So we're taking that 70524 and just need to add 3 zeros on the end. 1, 2, 3. So put some commas in here. 1 times 1 is 1. Look, we're already to a unit rate. So it is 70,524,000 grams in an hour. Now we're finally to the last question. We are going centiliters to liters, and we are going from hours to weeks. So 85, let me go back here, 85,800 centiliters in 1 hour. And we need, let's deal with time first. So let's go hours to days. And now let's do another conversion of days to weeks. And that'll get us to weeks. So there are 24 hours in 1 day. There are 7 days in 1 week. And now we need a conversion factor to take us from centiliters to liters. So centiliters is in the numerator, so now I want it in the denominator. And we're going to try to get to liters. So let's think about this. Liters is the base unit here. Then we got deciliters and then centiliters. So it takes 10 of these. No, back up. It takes 100 of these to equal one of these. No, it doesn't. I'm backwards. Bigger number on the right. It takes 100 centis to equal 1 base unit. So 1 liter is equal to 100 centiliters. That is to say 100 centiliters is equal to 1 liter. So with that said, let's go ahead and I keep putting a double check my math on that, and yes, it takes 1,000 of those to equal, 100. So I'm good to go. Hours cancels hours, days cancels days, centiliters cancels centiliters, so we end up with measurement up in the numerator is liters, and the measurement in the denominator is weeks. Is that what we're looking for? Indeed, liters per week. So now we can go 85,800 times 24 times 7. Wow. Okay, so I better go ahead and use a calculator for that. 85,800 times 24 times 7 gives me a product of, I better make some room here, 144, 144, 00. And then 1 times 1 times 1 times 100 is 100. Now to get to a unit rate of liters in a week, I need to divide both numbers by the denominator, 100. 100 divided by 100 is 1. And here, dividing this number by 100 is going to be easy. I just knock those 2 zeros off. So I end up 144, 144. So 144,144. 144, 144. So 1,444,144. All right, so bump my mic there. So that completes all of my examples for IXL Activity A1.E.2 Convert Rates and Measurements using metric units. Remember, the key is either memorize this table or keep it handy so that you know how many units of what makes what. Understand that if we're moving to the right, the decimal moves to the right. If we're moving to the left, the decimal moves to the left. And it's all the concept of using these prefixes like kilo and centi and milli along with the root words, or that is to say the base units there. All right. And that's pretty much the metric system. So good luck with your activity.